Okay, welcome back. In this video we're going to look at finding the equation of a line between 2 points. So we're going to start off just with 1 point and the gradient. But if you don't know the gradient, they will give you 2 points and you'll need to use those to find the gradient. We'll get to that and we'll have a little reminder of how to do that. And so we've got a new equation. So I've sort of color coded it to sort of help work through it. So the blue x and y, eventually we're going to end up with something that is y equals mx plus c. So the blue x and y in this equation is that x and y there. So these are the x and y that we're going to still have in our equation at the end. The m and c, the gradient and the y-intercept, are the things that we're going to work out with our point and gradient. So essentially we need to substitute in the values that we're given in here. If we aren't given the gradient, we'll be given 2 points and we'll need to use m equals y2 take y1, x2 take x1 to find this first, and then we'll use one of these coordinates, doesn't really matter which one, to substitute in for this x1, y1, and then we'll rearrange it into this form. So let's put the box around that. Okay, so I'm just going to jump straight into these few examples. I'll do them one at a time. So the first one, find the equation of a line. This is B2.6. Find the equation of a line that passes through equation. I'll use that to abbreviate equation. Passes through. So I'll write this in red. -2,5 and has gradient 3. So I'm going to be using this equation quite a lot. I want you to have a lot of practice at substituting numbers in, rearranging it into this form, so hopefully this will steer you in the right direction. So we're going to call the point is x1, y1. So x1 is -2, y1 is 5, and this is our m. So I'm just writing those underneath so that you understand what values to plug in, and we'll just jump straight into this. I will also show you another way you can do it, but we might just run through these examples first. Right, so y take away, I'll write it out again, equals m lots of x take x1. Usually you'll get a mark just for writing that, knowing that this is what you use. So let's substitute in y take away 5 equals 3 lots of x take -2. So I'm being careful when I've got two negatives together. So the first step is to multiply out these brackets, not forgetting that this is essentially x plus 2. So we're going to get 3 multiplied by x is 3x, and this is plus 2, so 3 times 2 is going to give us plus 6. Y take away 5, going to run out of room. And then all that's left to do is we're going to add 5 to both sides. So let's just write it like this. Equals 3x plus 6 plus 5. So that cancels with that. And we get y equals 3x 6 plus 5 plus 11. So as soon as we get it into that form, where we have a gradient plus our constant y-intercept, that's the equation of the line with this gradient, because there it is. So if you know the gradient, it's always going to be that number, and it passes through this point. So essentially, if it has a gradient of 3, it's going to be sloping that way. But if we want it to pass through this point, it's got to shift up so that it passes through 11. I think that's probably the best way to describe it. So that was really just substitution. The next example, we're just going to be given 2 points, and we'll have to do this step first. So hopefully that made sense. So our x term in there, our y term in there, our gradient there. So I might just get rid of that as well. I'll give us a little bit more space. So our next one, find the equation of a line that passes through, and I'll just write these as 2 points. -1, 4, and 4, 14. Right, so I might just, so we're given 2 points, so we're going to have to use both of these points with this equation first to find the gradient, and then we use one of these points. I like to use the one with the smallest numbers because it means that when we plug them in here, we've got less maths to do. Right, so let's call this one x2, y2, x1, y1. So first of all, we're finding the gradient equals 14 take away 4 over 4 take away -1. So this is 10 over 4. That would make that 5. So our gradient is 2. Now we've found our gradient, we can use either this point or that point. Once we've got past this point, it doesn't matter which one of these you've called x2, y2, x1, y1, just as long as you use one of the points. So we'll use this one. So we're going to go y take away 4 equals our m that we've worked out, 2. Lots of x take away -1, so I'm just going to convert that to +1. Take away a negative is the same as plus. So the first thing I'm going to do is multiply out these brackets. So this is 2x plus 2. And that's still equal to y take away 4. Then we'll add 4 to both sides. So that cancels with that, and we get y equals 2x plus 6. Just to show you that it doesn't matter if we use this point instead, I'm going to do this same calculation except with this point instead of that point. So we would have had y take away 14, same gradient, 2 lots of x take away 4. So let's take away a positive, so that's fine. So same thing, we'll multiply out the brackets first. So this equals 2x take away 8. Then we want to make y the subject, so we'll just add 14 but to both sides. That cancels with that. Y equals 2x negative 8 plus 14 plus 6, and they're the same. So it doesn't matter which point you use, you should still end up with the same answer, but I'm sure you can see that 2 plus 4 is easier to do than negative 8 plus 14. They're usually picking the one with the smallest numbers. Sometimes if you've got one with 2 negative numbers or 2 positive numbers, the positive numbers might be easier. Right, so we've got one more example, and we've got quite a few negative numbers in here, but we'll go through the same process. We're going to have to use this first to find the gradient, and then we'll use one of the points, and then once we've done it using this, I will show you another way you can do it just using this if you're comfortable rearranging. Well, you'll see. So our 2 points in this case are negative 9, comma 2, and 3, comma negative 1. So let's just give these names. Let's make this one x1, y1, x2, y2. And first we'll do this. So our gradient m is going to be negative 1 take away positive 2 divided by x2 is negative 3 take away negative 9. Don't get confused, that's going to end up being a plus. So we've got negative 3 over negative 3 plus 9 is 6. So this is negative a half or negative 0.5. Let's just go with negative 0.5. Okay, so now in blue we're going to substitute. Let's use this one for no reason at all. Probably because we've got a positive number in there. It's probably easier than 2 negative numbers. So we've got y take away 2 equals our gradient negative 0.5. What's of x take away negative 9, so that's the same as plus 9. First of all, we'll multiply out the brackets. So this is a negative times a positive, negative 0.5x, and then a negative times a positive is going to be negative again, and this is half of 9, 4.5. This is still y take 2. So then we'll add 2 to both sides, so that's just going to add 2 to that. And we end up with y equals negative 0.5x take away 2.5. So there's our equation. Now this other method that I'm going to show you, you still need the gradient and you still need 1 point, but it essentially substitutes them into here, and then you need to rearrange to solve for c. Essentially make the this number on the end the subject. And then once we've found that, we use the gradient and the number that we're going to find. So we should end up with this. So what I'm going to do, and we'll use this point instead. So our y value, we'll just substitute in there. So -1 equals our gradient, -0.5, multiplied by our x value, plus the thing that we need to work out. So if our point was -3, -1 with m equals -0.5. So there's our gradient, there's our x and y in our coordinates. So now we're just going to multiply this and then move the result of that to this side. So it's -1, change to red. Negative times a negative is going to be a positive. 0.5 times 3 is half of 3. Positive 1.5 plus this thing. And then we're going to take 1.5 from both sides. That cancels with that. And we get -1, take away another 1.5. And we find out that our number on the end of our equation, and they match. So once we've got C and M, you still have to go through this step here. We can then just go, oh well, our equation must be y equals -0.5 x, take away 2.5. So that's, if we write it like that, if we substitute our point x and y in there, it doesn't matter which one we use, and we know what this is, we multiply them, bring that to this side and combine it with that, we find out what this number on the end is going to be. So that might be another way that you want to try doing it. And basically, as I keep saying, you just really just need to do lots and lots of these. Practice, and eventually it will start working out. Common mistakes that people make is they go, well, that's x1, x2, y1, y2, and so they plug the wrong numbers in here, or they get y2, y1 the right way round, but then they have x1 subtract x2. So they get one of the numbers either on the top or the bottom correct, but the other one is back to front. Sometimes they put the x values on the top and the y values on the bottom. So just this is on the formula sheet. Make sure you look at it and you use it correctly, and with this you only need one point, x1, y1. Doesn't matter which point you use once you've found the gradient. Right, so that's where I'm going to end this video. Hopefully that will get you started on using these equations. Right, see you in the next one.